CSR. Nick is a senior technical engineer for Hebel. He's done, prior to working for Hebel, he was 3 years with Jacobs Engineering, doing structural engineering and civil engineering, and now he's CSR's lucky to have him here for the last 3 years. So I'll hand you over to Nicholas. Please make him welcome.
Alright, thanks for having me here, guys. I appreciate it. I'll just be here to talk a little bit about reinforced autoclaved aerated concrete. Is everyone familiar with this material? Yeah? Okay, so I'm sure you guys heard of us. Now, typically when people see AAC, they straight away think Hebel. And that's just because in Australia, Hebel is the only manufacturer of AFC. But there's a lot that comes from the overseas side of things. We get a lot from China, Thailand and Malaysia, and a lot of them don't comply to the current Australian standard. So I'll speak a bit about that today. So the standard for ASCs, AS5146, actually been released a couple of years ago in 2015, and prior to that there was actually no standard for AAC, so there was no real benchmark or guideline for anyone to follow. And it all kind of came in a combination of things. It came a combination of a couple of standards, like the standard masonry standard, 3700, concrete standard, even European standard. So there was a lot of confusion as to how we monitor compliant structures that are built with AAC. And a lot of the stuff came back to the European because it's been built for a very long time in Europe and it's been proven in Europe. So that was the process, I guess, back in the day. However, now we're starting to clamp down on these sort of things. So it was an important reason for these standards to come out. Not sure if you guys are familiar with the actual standard. So why the AFC standard was important to come in is because there was questionable quality in terms of these products coming into Australia. And when you see a product that comes from overseas and you can see the product that's manufactured in Australia, there's very clear differences, and it all mostly would come down to the durability of that. In terms of also creating systems, the overseas market would just create panels or create the product itself and ship over, and what would normally happen is on drawings they'll be specified, say, as Hebel, but then they do a switcheroo and they chuck on some Chinese product or a Malaysian product that isn't actually compatible with the system or hasn't actually been tested specifically. But because it looks the same, no one questions it, and they all think that it's Hebel. So there was an important, I guess, reason why we had to bring in a standard to make sure that product conforms to the Australian standard. So this here is actually a photo of a product from overseas. So it does have poor durability as you can see with the reinforcement. So all AAC product is a little bit different to concrete. And some people don't know that with concrete you need cover to protect your reinforcement. With AAC you won't get more protection to your reinforcement if you increase that cover. So if you have a 300 thick panel, for instance, and you put reinforcement in the middle portion, you've got almost 150 mil cover. That's not actually going to benefit if you don't have any anti-corrosion protection paint on your reinforcement. So it's anti-corrosion protection paint that protects the steel and provides the durability for the reinforcement. And if you don't do that, it's obviously going to start to rust and your panels will start to spoil. So you're going to get breakouts just like this. So this is actually a section that had spoiled away. It's not actually something that anyone had gone in for investigative works and digged out. Now, issues like this, you start with spoiling or you start with corrosion occurring, but it does also affect the fire performance as well, and obviously the structural performance. Fire is important because as the structural performance of the panels reduce, the fire relies on an amount of structural adequacy of the panels and the system hold together as it deflects in a fire, and if that structural stability isn't there, the panel will actually just fall apart in the fire. So it does kind of start with durability and ends up going into structural and fire issues as well. Now with Hebel panels, we actually have our reinforcement dip coated, and we've done accelerated testing on that to prove up to 50-year durability to meet the NCC requirements. So in terms of specification and design and construction, we tried to make it easier with the integration or the introduction of AS5146, which is the Australian standard for ASC, because we needed to make sure there's a minimum benchmark on quality and ensure that there is a material that's suitable for the Australian market. Now, in terms of the standard, it comes down into three separate parts, and I'll just briefly explain about what those are. The first one is just your typical section which outlines the overall sort of standard, the requirements for load combinations. It talks about your reduction factors. It has material properties in there. It's only a pretty small document, the first part, which is only about 12, 14 pages. Now, part 1 is actually referenced in the NCC 2016. So when this came out in 2015, there was no reference until the 2016 NCC was released. And from there, we're also referenced into 2019, which is coming out next month, as you all know. So now that we have part 1 reference, we form under the DTS provisions of the NCC. But there are 3 parts. Part 1 is the only one that's referenced, but in part 1 it also references part 2 and part 3. So that's where the compliance pathway flows. NCC references part 1 and part 1 references 2 and 3. Part 2 is the design section which engineers would actually use. So the engineer would be able to design their own Hebel panels, or let's say ASC panels. I'm conditioned to say Hebel every time, but ASC panels where they could look at material properties specifically, because we actually have a few different formulas of material properties for E values and things like that, and we have different densities as well. So we can have someone come up to us and say, we want to design our own panels, and we want to do some floor panels, say. We would give them some parameters for them to design, and they can actually design their own. Now, typically, they don't go away and design their own because we have our own standard procedures and standard reinforcement that we use. So if they give us the loads, we actually design it for them, which makes it a lot easier for everyone. So as long as the engineer commits to loading that we can then use, and for some reason, not all engineers are comfortable with giving their numbers. I'm not sure why. I mean, coming in my previous role in consulting design, if I was working with a company that was giving me like a precast company, you would give them your loads and you wouldn't ask any questions. You would rely on them doing the design to the relevant standards, and then they would come back with a panel that's suitable for use, and then that would be delivered on site and go from there. But for some reason, some engineers just don't like to pass that on. So the part 2 is that design, so you can get all your capacities for your panels and your durability requirements and things like that. It also has an important section in the back in the appendices section, which outlines all of the testing requirement to ensure that your panels are suitable, for product conformance of your panel back to Australian standards. So to get your mean dry densities, your characteristic compressive strengths, all your material properties, there's about 20 different tests. Not all of them are relevant to Australia or maybe certain regions of Australia, but in saying that, it covers all of the material properties for ASC. And without having compliance to those sections, you haven't got a product that conforms to the Australian standard. So we find that a lot of overseas products that come into the market won't really have any references back to 5146 and don't actually comply to the standard, which means it doesn't comply back to the NCC. NCC reference the standards. And then part 3 is actually a construction standard, which more builders and I guess you guys would be more interested in. And it actually outlines and contains a lot of diagrams and details for how certain systems come together. So it doesn't doesn't specifically go into the detailing of the material properties and things like that. It's all done in the Part 2 section. This is just all installation details. So it's quite a thick document, I think 200 pages, and it's just full of details. Depends on the type of system that you're going to use AAC for. It gives you all your flashing details, window penetration openings. It also has structural design tables for number of battens, number of screws that go into each panel. So it's very easy for a builder to pull that up and then reference exactly what they need for their systems. And these are some of the systems that are in the standard. So there's houses and low-rise external wall systems, there's low-rise intertenancy party wall systems, 75mm AAC floor systems which require a joist frame for support. You've got structural flooring, which is 150 to 300 self-supporting panels, and they can actually span up to whatever the design of the panels can be. And you've also got the high-rise facade, which I'll talk a little bit about how they will come together. And these are some details that are in Part 3 of the standard. There's a whole mirage of details, and it's quite overwhelming if you just flick through it. But if you look for your specific system that you're looking at constructing, you might even be on site. You can actually kind of look at what's being built, look at the standard, and make sure that's being built that way. So yes, like I said, Part 1 is referenced again in NCC, and then Part 1 references 2 and 3. So that's your compliance pathway. Now I'll talk a little bit about just the Hebel systems here, and I'll sort of touch base on those ASC systems that were in the Part 3 of AS 5146. But these ones now, I guess, are more specific to the Hebel. So with our systems, we get our compliance for fire, weather tightness, thermal, durability, all of that to encompass the system together. And with that, we also get code marks on our system. So with all the Hebel systems, we get compliance documentation from all independent consultants, and then we package it all together in a code mark certificate. And that's how we encompass our compliance documentation. Now, code mark, I think, has been under fire, in more recent times on certain products or systems that they've actually certified. But in saying that, there's been no effect on any of the Hebel systems. And they're actually going through a more rigorous process. I'm not sure if anyone's familiar, but they're doing a more rigorous process of going through and auditing all of the systems that they've already provided compliance for. And they're reviewing all of those documentation. And it's actually a yearly process which costs thousands of dollars, depending on how many systems you have with them. So they're being a lot stricter and tighter, including more information in the certification. Whereas before it used to just be a simple one-pager, it's now like a 7-8 page document that includes all of the components. So that certification was passed on to someone, they know exactly how to install the system, as opposed to before you just see certification, you might only say this system is certified by CodeMark, and that's it. So it's becoming a much more transparent process and making it a bit easier for people to know exactly what they're specifying or installing or designing on their projects. So this system here is the residential external wall system. It's a vertical cladded system, and we've actually got now 50mm and 75mm Hebel panels that go onto horizontal top axle battens that fix back onto stud framing. So one of the major questions that we get asked, or we actually see on site, is direct fix straight onto the stud frame, and that's not how the system is to be installed. The battens allow for movement for the panels, or thermal expansion and contraction, or any little settlements that occur. And also it is a phase sealed system, so you rely on the render system and coding system to protect for weather tightness. We do find people sometimes for this residential system put weep holes, and that's already compromised your weather tightness performance. But we do have a secondary sarking layer to protect against that, but the system is compliant for a phase sealed system, not a pressure equalized system. So it's something to look out for. And sometimes with installation, obviously that's been the most important thing of how they install their control joints, and are they rendering over control joints? Are they going to get cracks in their render system? That's going to ultimately compromise the system altogether. So these are the sort of questions that we ask, or what we see with the external wall systems with Hebel. This one here is probably not the best image, but it's a high-rise external wall system, and it's similar in the sense that it's a vertical panel system. It's a 75mm thick. We're actually working on a 50mm panel system at the moment. It's just in development now, and we're getting all the compliance for that. And we'll be going through code mark also for that system. But the one that we currently have compliant is a 75mm system, and that gets fixed back onto horizontal top hats also, but back onto a steel stud frame. So the residential system has a steel or timber stud frame option, whereas with the high-rise system, it's all steel stud frame. And one of the main things that architects like to do with this system is try and reduce the wall thickness as much as they can. So they start trying to introduce thinner top hats, and they don't even ask half the time. You go out on site and you see a 16mm top hat, which is bugger all, or 20mm. We actually have a 50mm top hat for the system, and it's a pressure equalised system. So you have a weak hole in, and you want the cavity to breathe. You want the cavity to remain pressure equalised. So we do have that 50mm, and it's been specifically certified and compliant for a 50mm top hat. And any system elements that do change, obviously, is a variation to the standard system. So if you change any element, then obviously it's then back onto the PCA to review and sign off. And obviously in the kind of market or in the timing of the industry now, it's getting harder and harder to get that sign off from PCA. So they're becoming increasingly more uncomfortable, which totally makes sense in the sense of a builder or installer installing not to the standard details, and then questioning back onto CSR or Hebel as to whether they can change or swap out elements of the system. And it's not in our kind of jurisdiction, or we don't have the power to actually say, yes, you can change it out, because we are not a certifying authority or body that can then sign off to say, if you use a 20mm top hat, or if you use a different type of panel, you will then have system compliance for that. So just got to keep out for that. For any system that is certified, it must be installed, and all the elements must be the same as the certified system. The low-rise or residential intertenancy wall system is basically a vertical Hebel panel in between two stud frames. So this is an interesting one, because you have to consider acoustic performance in this case between two tenancies, and how we do that is by running a vertical panel straight up. We have aluminium brackets that are fixed at the top and bottom of the walls only. We don't have intermediate fixings. That way we can actually achieve discontinuous construction over the wall height. If you were to have supports throughout that wall height, you won't actually get discontinuous construction unless you start putting resilient mounts and things like that for your lining, which becomes a lot more cumbersome for installation. So builders don't normally like to go down that way. So we designed this to have aluminium brackets on the bottom and top. And some people ask, why aluminium? Can I use steel? You can't, because with aluminium you need to consider, in a fire case, if one tenancy is burning, what's going to happen is that frame will end up burning out. And if you don't have the bracket burn out with the frame, then it will just tear the wall down when that side of the frame falls over. So it's the aluminium bracket that actually melts in a fire, and that will melt before the frame ends up falling. So in terms of compliance, you have these two frames. You've got a fire on this side, the frame and the aluminium brackets will end up burning and pulling apart from the Hebel wall over here. But it's this frame here that holds the panel together to make sure the fire compliance is still there. So you have one side doing the work while the other burns away. So it's ultimately a sacrificial system, but that's the way the system works. So you need there's two stud frames, on either side of that panel, and that's how this system comes together. And maximum height, we have also up to 15 metres for this one. Now this is a high-rise intertenancy wall system where it's basically just fixed at top and bottom with some steel slotted angles. And a lot of people ask, do we need specific linings to get our fire ready? Do we need, fire check linings and things like that to get a 90-minute FRL? But you don't. The Hebel panel itself achieves a 90-minute FRL, and we have two different types where we have a single mesh panel that goes up to 3.3 meters, and we have also a cage mesh panel which goes up to 4.65 meters. Single mesh that goes up to 3.3 achieves 90 minutes, and the cage mesh that goes up to 4.65 achieves 2 hours. So we cover most cases in this here, and we also have additional thicker panels, 100mm and 125 thick panels as well. They get a bit too heavy on site. Now, we market ourselves as a lightweight system, but if you work with Hebel and pick up 3-meter panels, they're bloody heavy. So you need a few guys out there, and if you're installing panels day in, day out, you want to try and make sure you're using thinner panels as opposed to just 100, 125. You need a bit more heavy machinery. You get a few big blokes to carry them. It's still a lot of hard work. The 75mm flooring system is basically fixed over joist frame, so typically 450 or 600 joist frame, up to 5 kPa total loading can be applied on the floor system, so it caters for most residential and some commercial implications or projects. Now, with these systems, screws just get fixed straight through the panel into the joist frame, so it's all kind of interlocked together, and we're only spanning a small amount of distance, and that's why the panels can be only 75 mm thick. So this is a good option when you're looking at soundproofing or maybe reducing the noise through a floor level. And I've got a friend of mine that actually recently constructed with Hebel flooring, and he said it's great when his kids are running around upstairs, he can barely hear it downstairs. So it seems like there's some real benefits while getting a solid floor as well. The flooring system also comes in thicker panels as well. What is shown here is you see that there's reinforcement coming out in between the joints of the panel. Now, these thicker panels range from 150 all the way up to 300 and can span up to 6 meters long. So the longest Hebel panels that we manufacture are actually 6 meters long. That's because the mold cars that we have is 6 meters long. But in saying that, depending on the loads and also how far your beams are, it's anywhere between 0 and 6. So with this system here, we have up to 3 hours fire rating for these panel systems, and we have a ring angle system, which is what you see there. So there's reinforcement that goes between the joints, and the panels are specifically profiled, have a little cutout, notch out, where the reinforcement sits, and then you put the grout to interlock that. And that has diaphragm action that you can actually, engineers would use for design for buildings to cause that diaphragm action. They don't need to rely on other members of the floor to provide that, which is great. And we're finding that this type of construction hasn't been fully adopted over in Australia. There's mostly with the big builders, they like to use concrete floors. It's just something that is conventional construction, but we do have some builders that like to install with a steel frame and then actually put panels on top of that. So that's been working quite well in those buildings. And in terms of time for construction, it speeds up the process because you don't have to worry about curing times and things like that. You just get your steel members, bolt them all up, and then craning all of your panels down, put in your reinforcement and grout, and you can keep working. You can actually keep working over the panels even if the grout has not fully cured. I'll talk a little bit about just the Hebel Technical Services team, which is what I'm part of. So it's currently a 4-man band. I'm the senior in the team. We've got 2 juniors and the team leader. And typically how inquiries work is people contact us, so we'll get calls from all sorts, from the industry, architects, engineers, building surveyors, anyone that's interested in our system, even homeowners. And they would call through our National Construction line, National Call Centre line. I would say NCC was the National Call Centre, but NCC is National Construction Code, so always confusing. And they effectively give us any leads coming through from people that have inquiries, and we would then service them. So initially there will be a bit of a desktop study that would be done, and that could be done by the technical team itself, or maybe if it's a more straightforward inquiry that comes through, the BDM can also handle that. So it's kind of a relationship between the BDMs that we have that go out, because they're also knowledgeable in the technical side, and we do with the more tougher compliance side of things. And there's times that we need to also go out on site, make sure everyone's happy, and be seen on site at times. You know, we don't like to just sit behind the desk too often, because people start calling you all sorts of names out there because you're not going out to site and trying to help with the issue. So we do try to help where we can. We get issues at times that come up and we might not have a resolution at the time. But what we do, if we start seeing a common problem come up, and we have a whole register of things that come up, and we get analytics on all of the inquiries that come in, we then start getting these trends. And with these trends, we might find certain penetration details are desirable, and at times when we don't have that specific compliance covered, we then would need reliance on the fire engineer to review and look at an alternative solution for that, where the PCA then reviews, because it's outside of our compliance. But in saying that, when we pick up certain trends, we actually work on getting that done, getting the compliance completed, using independent engineers or independent consultants. We use CSIRO and Hebel Warrington Fire mostly. We also use some other fire engineers to provide this sort of compliance documentation. So they will review specific cases and they'll give us compliance documentation. We can then market or provide that as a standard solution, and we update our design guides accordingly every time we update our fire report. So there's a specific report. This was an example of one where we always started seeing these pipe penetrations going through our head connection details. And typically we always just said, no, you've got to have the pipe penetration lower and not actually cut out the angles. So you'll see the angles here, they actually cut out, and that's right underneath the soffit of the next level. But what we ended up doing is going back to Hebel Warrington Fire and talked about getting compliance with that, and they provided an option of providing a bit of a 5-chip lining just around that penetration on both sides and sealed around to make sure that we can get compliance on that. And we were actually up to revision 21 of this report, so we just keep adding things in every time. We'll typically get 3 or 4 or 5 different new details, and we'll update that all in one go as opposed to one at a time. Now we have a lot of resources and technical documentation on our website. I don't know if anyone's actually been surfing our website. Sometimes we actually get calls and, where can I find this document? And people don't usually fish for themselves, but it's quite straightforward. It's just a download section there, and you can get any kind of documentation. We have technical manuals that give you all the material properties of all the different types of panels. We've got design guides for all the different systems that we have compliance for as well. So it's all very laid out easily on the website. These are just some examples of the design guides that we have, and we have some safety data sheets as well, but everything is on the website, quite straightforward. Now, one of the things I did also want to just bring to everyone's attention is we've actually just released a new specification tool, and this is something that we've just initially started with Hebel, and we're starting to bring in a bit of our other business units in. So AFS is currently in there as well. We use the permanent formwork systems from AFS. But essentially what it is a specification tool that's in our website. This is just actually our homepage on our website if you haven't been to it. And just up the top there's a specification tool section that I've circled in red. And that section there will take you to this page here. We can actually do searches on different systems. So you can, for example, see facade systems. You can filter through a number of different products. At the moment we have Hebel and AFS. We have different segments, so they might be high-rise apartments, they might be low-rise homes, townhouses, applications, so you might have intertenancy wall systems, flooring systems, facade wall systems, and region. Currently we have Australia and New Zealand. And this is an example of just putting in facade and on a specific Hebel product, and you would have a breakdown that comes through. You can click on the little thumbnail on the left, and that will expand into a full-size image, so you can confirm if that's what you want. And it also gives you other parameters for that system, such as wall width, which is very important to a lot of people to confirm, is this actually the wall width that we want? And then they have a few different compliance information. So we have the maximum FRL for that system, the RW plus CTR, and also the thermal performance for that system. And in the last column, there's a summary sheet as well for that system. So the summary sheet itself looks something like this, where it provides you with a system image, and it gives you all your performance information on the top left there, and it also gives you additional information and resources for that system at the bottom. And you would actually see there's references back to compliance documentation as well, just over here. So if you can't read it down the back, there are actually references for fire reports, acoustic report, thermal, weather tightness reports, and structural and code mark reports. So with every system we've linked into this database, systems that link back to all of our compliance reports to make sure that if someone looks at this system, they know that there is compliance and they can actually request those reports. So someone might look at this and say, okay, that's great, they've got a facade system, they've got a maximum FRL -120/120, which has up the top there. What is my compliance documentation I need? They look at fire report, and there's 2 fire reports there. So they can actually request and say, hey people, I need these 2 fire reports. I'm doing a sign-off for this structure. Can you send that through? And then we'll be able to send that directly through, and it relates to this system. There's also details for the design installation button here as well, so you don't actually need to look for those sections in the website. So this is just a new thing that we've had out probably for 5-6 months now, and we're getting analytics on this, and we're getting about 500 to 600 clicks on this a month at the moment, but every month it is getting more and more, so we are trying to sort of, expand that if we can and have more people use it, because there's benefit to everyone in the industry, not just architects or engineers, but also building surveyors and consultants as well. So that wraps me up. Is there any questions that anyone has, whether it's about ASC or Hebel or anything else that I can get?
Sorry, construction with the external.
Sorry, I can't quite hear. My hearing's not the best.
Okay, I'll stand. I've seen a construction domestic drawing. It's on piers.
Yeah.
People external walls, and the support mechanism is an angle up underneath that steel line going from pier to pier.
Yeah.
Is that a standard construction method?
So is this a residential build or?
Sorry?
Is this a residential build?
Yeah, residential.
Yeah, okay. Yeah, I mean, with specific projects, we would need to probably look at the details, and I can give you my card if you want to, shoot me an email or give me a call, so we can definitely discuss this specific case that you had in terms of when you look at specific projects. It does depend on what's there, so yeah, that's it. If anything else, maybe more generic,
Nick, external facade, you said, I think, 50 years to...
Yes, correct.
What kind of maintenance is required or recommended over that period?
Okay, so the coding system is actually part of that durability. So we have durability for the panel alone, and we also have for the coding system. Now, typically, it's the paint system is what needs to be maintained. The render doesn't need to come off, but it's the paint system that needs to be maintained. And depending on the paint system that we put on as a final coat, it would be a 5 or 10-year application. I mean, typically with paint systems, that's what you're looking at. If you've got a really good paint system, maybe 15 years, maybe 20 years, but you start pushing it at that point. But it all comes down really to the final coats that you're applying in that wall, because that's really what's being exposed to the sun and the elements.
When we're describing the property, do we describe it as an AAC panel rather than Hebel, because we can't really tell whether it's inferior product or whether it's original coating?
Typically when anyone sees AAC, and the correct term would be AAC, because that's the material, it's like looking at a precast element that came from Humes. You wouldn't call it Humes, you would call it a precast concrete element. But in saying that, because Hebel is what's known in the industry, people assume Hebel. Now we have sometimes cases where a project will come up and there's an issue. The first thing that we do, we actually check our database if that address is in our system, and we can also verify by investigative works if that's a specific Hebel panel. But we are usually generous with our support, and at times there's maybe not full confirmation to know that that's a Hebel system or a Hebel project, but we do try and support where we can. But typically it's ASC, not Hebel. But in most cases you'll find that it's a Hebel product. Yeah.
So, pardon me, so Nick, does that mean that, so if you are looking at an AAC panel, you're not sure whether it's Hebel or not, you can be contacted and asked whether it's Hebel or not because you've got it on your database?
Yeah, so typically on the database we do have, there are some projects that we wouldn't know because they might be going through our resellers, and we don't get that sort of information coming back. So if they're going through resellers, it's normally just a smaller, say, residential job, as opposed to a larger job. All the commercial jobs, they're all in our database because they come and are bought directly from us. They don't go through resellers. But with the smaller stuff, they might have gone to a major reseller that provides our panels, and then we wouldn't have that information there. So we do get times where we don't have it, but we can also ask questions about the system to confirm whether it is our system. When we start seeing different elements that aren't our system as well, and the installation as well doesn't match exactly what our system has, that starts raising questions as to whether it's a Hebel system. Yeah.
You mentioned the Australian standards, and CSR has been involved in developing that, is that right?
Yes, so we have a member that's on that panel. So there's a few members, I think it's a 5 or 6 kind of delegates that come together and they meet every now and then. We have one person sitting in CSR, there's also some competitors that are in there as well. And there's 2 independent engineers that are also part of that team. So as a whole, and they all need to collaborate together to make sure that one's not favoured more than the other, and that all the systems that, say, everyone in the industry is in can still have their systems. If CSI was pushing for certain systems to be published in the standard, and the competitor was not getting that, it wouldn't be fair. We could actually be pulled up with the ASBC and things like that. So we need to make sure everyone's on the same playing field when it comes to this. Yeah. In the back?
Yeah, with your, you mentioned briefly the wall systems.
Yeah.
Durability, and you used the word paint system to protect it. I know you didn't use the word membrane system.
Okay.
And maybe you could expand on that, but
okay.
The second part of the question is the floor systems. We've all lived through the magnesite era. Wondering what do you do to stop floors bloating from water ingress?
Yeah, okay. So typically with the system itself, it is a rendered system. So it's an acrylic-based render system that is used. It's a paint system that is applied as a final coat on that coating system that gets on at the end. And that's what you need to maintain over the years of the building. Are you referring to, with the external wall systems, the low-rise or the high-rise system? Because the high-rise is a open cavity and the low-rise is a closed cavity.
Either, really. I guess the render doesn't necessarily provide a waterproofing barrier, does it? It's the coating that you apply over the top.
Correct,
so,
yes, that's correct.
But you use the word paint as opposed to a membrane.
Yeah, well, the coating system is formulated to repel water through getting through, so it is a natural watertight barrier. With the residential systems, that's absolutely critical because it is a face-sealed system. Although we do recommend sarking being put in, we do find some builders not actually include that because they know it's a face-sealed system and they purely rely on the coating system itself. I did mention paint, but I meant coating. So with the coating system, getting that weather tightness performance for the residential system is where it all comes from. And if the coating system is compromised, then you compromise the weather tightness performance for that system. With the high-rise system, it's a little bit different because we do have the weeper slots for drainage and any moisture that builds up in there. We have a wall wrap layer in there, and it's a standard pressure equalised system for the facade. So in terms of the coating system, it's similar to the residential, and it still has that watertight barrier. But in saying that, if you do get any moisture from condensation making its way into the cavity, then it can actually flow out, and because the cavity is a breathable cavity, that will dry out over time.
So the product doesn't break down?
No. So the product itself, Hebel is actually kind of like a sponge, and any moisture around it actually absorbs into it, and the coating system itself allows for that moisture to evaporate from the base of the panel, and that in itself, you don't have, I guess, a moisture environment that maintains behind in that cavity. So you end up, if you have a kind of a wet few weeks or a wet month, it ends up slowly drying out through that pressure equalization over time.
So the reinforcement has got a protective coating on it then?
Yes, correct. So in the manufacturing process, the entire cage gets dip coated, and that coating itself is 50-year design life as well. So we've got accelerated testing specifically on the reinforcement also. And because you guys also know that Hebel is easy to cut, that happens all the time on site, and we've got a brush-on paint that goes over that as well. So it's a slightly different formula, but it's from the same manufacturers, and that one's an air-cured product. So the typical dip-coated one is a autoclave cured product, because that gets manufactured in autoclave and cures under that pressure and heat.
50 years is not a long time, but is it?
Sorry?
50 years is not a long time, but
Well, I mean, that's what the NCC requirement is.
sorry?
So for buildings, it's a 50-year design life. That's typically what is required. So yeah, I don't know who was first.
Big one.
Yeah.
In your experience, historically, where have the major defects been with the system?
Okay. Which system would you like to talk about? Because they're all kind of unique in their own ways.
We'll start off with roads.
With low-rise, okay. With low-rise, we find that most of the issues with defects coming to the installation of the coating systems. So we find that control joints are rendered over. We find that they put too thick of render on the system itself, because it's an acrylic system. It needs to also bridge any hairline cracks that might form due to settlements and movements in that wall. But when you provide too thick of a coating, and we have a specific specification as well as to the thickness that needs to be applied, that can start affecting, because you've got different thermal and compression coefficients for the render and for the actual panels themselves. So you start getting hairline cracks form, and if your coating system that's bridging that ends up cracking, your weather tightness performance is impacted from that. So with the low-rise external wall systems, that's one of the main issues. With the facade systems, high-rise external walls, it's not so big, because it's a pressure equalized system, and it does allow for an amount of moisture making its way in. However, in saying that, you don't want to be having cracks in there and introducing more water to the system. So it's paramount on insulation of the coating systems. That's a major part, and making sure all your control units are installed correctly. We do see on a lot of projects as well, I'm sure that this is consistent across all systems that are installed, where they either don't put backing rods, or they just squirt a little bit of sealant to look like there's a proper control joint, and after a year or 2 years, you start to see that start delaminating from the substrate, just because of a little bit of movement and expansion and contraction, and that already just makes for a direct pass straight through the wall. So,
What about openings?
So with openings, typically for internals, you're referring to? Yeah, so with internal walls, we do find with openings, we're getting, I guess, more and more combinations of things. There's a lot of products on the market as well, like fireboxes and intumescent kind of foam, maybe not foam, but they feel foamy, or it's like it's TBA have this sort of product, and you can cut like a section out put that in, and it's intramesh material, so you can put as many pipes in as you want effectively, or that's how they market it, and that kind of stops, you know, any path for smoke and can crush any plastic pipes as well. But I guess the question sometimes gets asked, are we compatible with other products? And they might make a penetration for, say, a TBA Firefly product, but they ask the question, is Hebel the one that has the compliance behind that? But it's not us that do the tests on that. TBA actually do their own tests, or these other companies do their own tests, so fire collars and things like that. We don't get all the manufacturers' different types of collars. They do their own testing with the wall systems. So making sure, I guess, the fire rating products that you might use in a wall system need to be compatible to that system. And yeah, and I guess just the different combinations and sizes of penetrations is something that we do see a lot of the time. Yeah. Yeah.
Just with your expectation of builders who might change from, say, a brick veneer system of low-rise external walls to an Hebel system where they screw into the frame, as opposed to bricks that sat on the slab edge and were self-supporting and sort of protected the timber frame. Whereas now we're screwing onto that timber frame, adding a greater load onto that slab at that point, and potentially increasing the wind load. Is there an expectation of the builder to have the structural engineer alter his slab and frame for those additional loads? Because we've seen with a couple of builders that tried to switch to that system, didn't upgrade their slabs, didn't upgrade their timber frames for different loadings, and went ahead. So is that an expectation of Hebels that it will be treated that way?
It would be an expectation that the frame is designed to withstand that lateral wind pressure that's coming on. And if initially they didn't design the building for that lateral wind loading to be applied, only just supporting internal pressures, then you're going to have an insufficient design for frame. You're going to get more deflection than what you really should, and you probably get cracking in your system as well, which is definitely not what you want to do. In terms of the framing, that usually comes back either from the framing manufacturers or just, you know, the builder itself, to make sure that the stud spacings and things like that are suitable for use for that system and that region that they are. So obviously the wind load will, you know, depend on where you are in the world or in Australia, and the frame needs to be specifically designed for that.
And with the period
Thank you very much, Nicholas. That's okay.